Hi everyone. Can I have some thumbs up? See, I want to see participants here. Panelists, I can see you thumbs up. How about participant? Can I see some thumbs up? So before we move on, we have 1.5 hours today for this session, and I want to make it as quick as possible because we have 3 esteemed speakers who like to share their insights and thoughts. Ladies and gentlemen, welcome to Climate Governance Malaysia CGM Roundtable Session 2025. First and foremost, thank you for being here. Thank you for attending this session. Definitely, those who are here, you are passionate about sustainability. You want to know more about what is all this about sustainable construction, or even to the extent of what built environment. You want to make a change. That's why you are here. Let's move on a bit of that CGM Roundtable series. CGM Roundtable series 2025. This is a collaborative platform where the whole idea is we bring together policymakers, industry leaders, academicians, corporate players. All of us are here with one objective: to put our thoughts together to come up with a practical policy and recommendation for Malaysia's climate issues or climate transition. This is our key thing we want to do. So speakers, please take note that this is, and speakers and participants take note. Today, we are not here just to discuss or talk. We want to capture real issues. We want to come up with a practical policy suggestions. That's the whole idea about this series. What CGM is doing, we have run this session from year 2022, but this year we have 19 sessions across 6 themes: biodiversity, agriculture, energy resources, finance, and our theme is built environment and community engagement. These are 6 themes. The details, you want further details, you can go to CGM website, you can go to CGM LinkedIn. All the details about our session and themes are there. This event would not be possible. This session not possible because our partners, Master Builders, Malaysian Green Building Council, REHDA Institute. This collaboratively, we are doing this session. So I have to thank all of these partners. Together, subject matter experts are going to share with us the insight today's session. And also, special mention to PwC Malaysia, because they are the one who are going to collect all this information, they have to capture it, and will be translated into action that we in that national level. Let's move on. About this roundtable, our topic today, we are focusing on circular construction, purely on circular construction, and it will be hosted by me as a moderator. My name is Ramesh. Presently, I'm a general manager with IJM Corporation. I have been involved in green building rating tools. Here and there, I've been a speaker for GreenRE and also for CIDB. That's my little bit of my involvement. And I thank you, CGM, for having me as a moderator to the session. What are we going to do today's session? 1.5 hours. We have only 1.5 hours. In this 1.5 hours, we will explore circular construction. We talk about how about low carbon material, technology available, regulators' direction of the policy, solution available, all with single thought, moving forward towards scaling up the adoption of circular construction. I mean, a key objective to come up with a concrete policy. This is today's session. And we have 3 speakers. Each one of you are given 20 minutes to speak about your mind, your thoughts, your ideas, your suggestion, everything. Because after that 20 minutes, we will have a moderation session. I believe there'll be a lot of Q&A coming from attendance of this club. If not, I have tons of questions for all of you. Without any delay, can we move on to our first speaker? Dr. Khairolden, are you ready? Yeah, you look like ever ready.
Yeah, okay. Yeah,
Ladies and gentlemen,
sure,
our first speaker. First speaker is Engineer TS Dr. Haji Muhammad Khairolden Ghani. He's a senior manager with Construction Research Institute of Malaysia, CREAM, under CIDB, a professional engineer, technologist with a PhD in built environment. He's a recognized industry leader in green building and sustainable construction. Both of us go a long way, Dr. Khairolden.
Yep.
I'm also impressed that recently you were given an award in 2025 as a distinguished industry practitioner in Bali. Congratulations. And you are also adjunct professor and advisory panel. Ladies and gentlemen, please welcome Dr. Khairolden towards circular construction, crafting the way. Dr. Khairolden, over to you.
All right.
Floor is yours.
Thanks, Ramesh, our lovely moderator. Right, you can see my screen, right, Ramesh? The full screen. All right.
Clear.
So, good afternoon, everyone. So, thanks for the kind introduction of myself. So, I'm Khairolden from Construction Research Institute of Malaysia, research institute under CIDB Malaysia, that looks into the R&D and also the development relating to this. One of the areas that we are looking for actually on the sustainability as well as the embodied carbon. And the task, first of all, I would like to thanks for the organizer, especially to CGM, as well as the course organizers from REHDA Institute and so on, right, for organizing such a very good platform to discuss, to to deliberate that people, everyone is talking about the construction, circular construction right now, right? So myself will present a little bit on the circular construction. How does the government, from the side, from the perspective of the research institution, as well as I would say that from the government, right, the policy, the direction that they are looking for. So, all right, so we move the second presentation. All right, second slide. You can see my second presentation. Can you see, Ramesh?
No, we cannot see it.
Cannot see, yeah?
No, it's not moving.
It's not moving, yeah?
Yeah.
Okay.
Scroll down.
It's
Down.
moving? It's moving?
Yep. It's moving.
Okay, all right. Okay, so before that, we try to look into the overview pictures as actually on the construction product where we are now. So actually, in terms of we have been many certification in Malaysia right now, but in terms of product certification, in terms of the numbers, it's quite small, I would say, because the product being certified rather than it's more the small numbers. And also the audit fees and lab analysis are too expensive. That means that the industry players are not afford to have their construction product is really get certified. And also there is no standard. The regular very specific standard that looks into the construction products per se, and also the certification program. So these are the things that when the people, the industry looking gears to environmental and social governance, there's some focus on the environmental criteria is being of the important element that we need to look into, right? So by having that different product, different criteria, so there are some jumble out of those are the things that problems that we need to cater one by one from the government, right? So these are the I think the quite pressing issues that we need to solve it out from the day one from now, right? So coming to that issues that CREAM as well as the CIDB and with the industry players have taken the step to introduce and one of the green product certification that not overlapping with the My Hijau, for example, not overlapping with the others certification, but this more on to complement each other. All right, so this is more on the voluntary product certification program that looks into the self audit assessment for the product itself. So we're going to have some of the objectives that we are looking for actually to step for the future standard for sustainable construction. And the second one to look into the mobilized to make sure that a wide range of the sustainable, the industry players itself to adopt the sustainable construction practices, as well as the continuous program that looks into the sustainable in the future, not in the future, but now, right? So some of the elements that component that incorporate in the sustain build mark, or in short we call it SB mark, actually looking into the not only for the environmental but looking into the other aspect as well to complement with the ESG what I call practices right now. So we also looking for the social governance practices to align with the requirement that by not only for the Malaysia but also for looking into the global practices, right? So this is in line with the impact improvement declaration with MS ISO 14021, right? So this certification, green product certification, actually is based on the product itself. I mean, if you have one product, so it's have to be assessed for that particular product itself for per location. So that means if you got 2, 3 or product, more than 3 product, so you have to apply for 3 product differently. So but bear in mind right now the cost, when people talk about the cost, the concern, the cost of application, the process, actually the cost that we offer actually as low as like Asia Airlines actually is very low in the market right now. So I think that one I don't need to reveal right now, but the cost actually is quite affordable for the manufacturer, right? So this is some of the offer that we can have right now. And once you process, getting through all the process, and then we have 2 components, a big component, one into looking into the criteria, and another one looks into the process of the assessment itself. So this could be the program Sustainability Mark is all about. So once the product is being certified, there will be listed in the official website for the SP Mark itself. So you have to get the I mean in terms of marketing, you get the publicly people know about your product itself, the green product that's available right now. So this or one of the initiative that we are looking for, right? So the second one actually we look into the opportunities, a gap opportunity in embodied carbon, right? So we have currently we're doing some of the study that looks into the embodied carbon itself to support for the circular construction, right? So before that, we have come out with the some of the gaps and opportunity that derive from the fact finding from the some of the studies, right? So we can see that from the in terms of local embodied carbon, right now there is no available in terms of standard, right? So these are some of the opportunity that we can look into, right? The second one in terms of database, right? Database sharing database is another challenge for industry players, right? Because we have to look into this based on the international database itself, so quite limited in the sense of a local database for embodied carbon, right? So in fact, we have done a few sessions with industry says many of them says that in terms of getting the data is quite difficult to compile. So CREAM and CIDB come into picture to help try to facilitate the embodied carbon database, right? The third one actually in terms of the regulation. So as of now, there is no mandatory embodied carbon reporting yet. So this is a time for us to look into that some of the standard that we are going to develop, and also some of the incentives that government try to offer to the industry, right? The EPD ecosystem itself, no local EPD program, but we have MyHijau. As for now, we have a MyHijau, but in terms of program as a whole, EPD is still not there, right? So, and last but not least, in terms of training and also training capacity, right? In terms of expertise, we have some limited in terms of technical expertise in LCA, but in fact, we do have that kind of knowledge, but to make more on the spectrum, the bigger spectrum, bigger capacity is not there yet. So we have to, the government, the CIDB has to look into this training capacity to give more programs for the industry to venture in, right? So those are the things that opportunity that we can see through the embodied carbon program. This is some of good topics, good research areas that we got currently is looking for, right? Okay, we go to the next, right? So these are currently as maybe not everyone is aware about this. CIDB has published what we call it the embodied carbon inventory database since 2021. So in fact, that embodied carbon inventory has been published in the CIDB official website, in fact a CREAM website as well. You can download it and then you can use as a reference. So as compared to the 2021 until the version 2025, there's a lot of different. We have updating. We have just completed the updating in terms of inventory listing of data, right? As compared to 2021, we just get 300 construction materials, but as of now, there is a incremental increase in terms of numbers, right? Under 629, so almost double increment in terms of listing of the construction material. We can see that the construction material is quite progressing well in terms of numbers, right? So in terms of building elements, in 2021 we managed to get 200 elements, but now we get more than 440 building elements. It's all completed already. So we will get to update and to upload in the CIDB and the platform for the reference once we got the green light from the CIDB to look into this. So the part of the embodied carbon inventory data is completed already in terms of updating all the information, right? So most of the embodied carbon inventory data is being used for the consultant, especially for the architect firm. So they use the CIDB embodied carbon inventory data for their during the design works, right? So that they are referring to the inventory database for that kind of the purposes. Okay, right. So we go next, right? So this another some of the effort that we have undertaken right now. So actually the development of embodied carbon calculator, right? So right now the embodied carbon calculator is I would say the first of its kind in Malaysia that will be developed using the digital calculator. So at the end of this study, we will have one of the guide that could assist the industry player to come up with the how much of the embodied carbon being calculated, right? Just by clicking just insert of the database. So right now we are in the midst of putting all the codes, everything, algorithm to put in the in terms of digitized mode of calculation. So this will be in the on the progress actually, and by end of this year we will try to complete this development, and hope so that after that we will get validation process with the industry to see how it can work. As for now, we have tested for one pilot project, and so far it's good to be used. And in fact, we have benchmark as well with the international bodies. For example, the Institution of Civil Engineers. We went to ICE. We went to RICS, Royal Institution Chartered Surveyors, to look into how they develop the embodied carbon calculator. But as for now, their embodied carbon is just more on the Excel format. So this Malaysia, we are trying to digitize that calculation so that it's more easy, user friendly for the user, right? So at the end of this development. So right now, as for the big companies, they have their embodied carbon database, but they are developed for their own only, not only for the calculation, everything, right? So for that purpose of the project. So CIDB and CREAM is looking for this for the publicly accessible. It's not meant for any project whatsoever, right? So these are the things that currently we are also looking for, and also we are updating the guidelines on the construction waste management, right? That one is in collaboration with our industry partners, YTL, Siemens, and Bhd, that look into the previous guideline that CIDB has been developed since 2008. So this is timely for us to update the database, the format, the reporting style. So all those kind have been in the other way, right? So that we can the guidelines can be used for waste construction, right? So because talking about the circular construction, waste management, waste construction, and demolition waste, part of the big agenda for the industry players as well, right? So I think for the way forward, right, towards the circular construction, there are three things that we need to look into this. Right. So first one, we have to accelerate our green certification product across the industry. This is a journey. The voluntary scheme is not mandatory right now, so we have to promote the SB mark. Because it's due to be launched, the SB mark, end of this month during the International Construction Week at MyTech, Kuala Lumpur. So this would be the the milestone for the green certification product to be marketed for the to make the more greater height for the industry looking into the sustainable, right? The second one actually to leverage the carbon calculator and waste data for better decision. So right, so as I did mention just now, we have some kind of the effort looking into the embodied carbon. We have a few reports looking into greenhouse gases, the embodied carbon database inventory. We have also doing right now the development of the carbon calculator guide. So these are the things that will help the industry in terms of looking into the whole life cycle based on the planning and also material selection, right? So the third one actually to come out with the sum of incentive. Yes, of course, we do have some of the offer incentive for those who are registering for SB Mark certification program. So, but nevertheless, we need to have more on a broader incentive from the government itself to come out with the to help out the industry players to come up with the to support this some of the sustainability program, right? So in terms of waste regulation and in terms of action plan that we need to come together, right? In terms of policy alignment, we have to align with the industry and also the government perspective, right? So those are the things that we need to look into the strategy as a whole, not only from the government but also looking into the both perspective, right? So I think just some of the overview of my presentation. I think that's all for my side, right, Ramesh? I hand over to you, right?
Dr. Khairolden, thank you for that insightful presentation and taking us through the insights of the policymakers. I believe you shared also the issues that you're facing.
Yeah.
And also thank you for sharing what's in the pipeline from CIDB and CRIM.
Yeah.
Thank you.
Thank you.
Due to time, now I will limit my comment. I'll move on to our next second speaker.
Yeah. I'll stop sharing.
Yes, please. Ms. Mei Si, are you ready?
Yes.
Okay.
Allow me to share screen.
Well, introducing you. Ladies and gentlemen, let me introduce you, Ms. Mei Si. She's a co-founder and the deputy managing director of CRT Manufacturing, the company behind Starbus. So she's going to share with us quite a number of things of the new material available. Starbus is a Malaysian certified nanotechnology based on a GFRP. What is GFRP? She will share with us. And she's been very active in contributing to the national and green construction standard. A profound speaker. I think I'll welcome her and she will take us through that material available for us. Mei Si, over to you.
Can you all see my slide number 1 in presentation mode?
Yes.
Okay, great. So thank you for the organizer for inviting us. I love the topics. Green climate change we combat against. So from introductory of my title, as a co-founder of CRT, I'm also one of the inventor for Starbus. Starbus is the brand, stands for Strong Tensile Anti-Rust Rebar. Obviously, the technological terms for it called glass fiber reinforced polymer, GFRP rebar. So for those who are first timer to this, we are here as an alternative to the conventional steel. We have received our MyIPO patent granted under the number MY208473-A this year. It falls on 12th of May 2025. So as a patent recipient, we are novel for the world. So what is actually GFRP? So GFRP, the first statement I would like to highlight, it is greener than blast furnace steel. It reduced 75% of carbon emission.
Mei Si, yes, for the slides are not in a presentation mode.
Oh, okay.
All right. Thank you.
Share screen. So is it in a presentation mode now?
No, yes, yes. Great. Thank you.
Okay, great. So GFRP is an alternative reinforcement to the steel. It reduces 75% of the carbon emission compared to the conventional steel. So stay tuned to my further slides on scope 1 calculation, not yet. Scope 1 calculation on the carbon emission. So compare this material against steel. If you look at the photographs at the back, that is the real photo from my warehouse. Actually, I would like to conduct my presentation today without the covering my background. But unfortunately, that's the format set by the organizer. I can just put up not live photo. So it is 4 times lighter in weight. So for those who had never seen this before, it is not plastic. I know it looked like plastic, but that is gold color, our corporate color. My bosses or my shareholders, most of them like this color, so we remain this color. So technologically, compared to conventional steel, it is 2 times stronger tensile strength, landed at, say, my T5, 5 mm bar tested at 1,500 Newton per mm square. And then this material is corrosion free. And as a Malaysian, the last most important point, cost saving. Please stay tuned to my slides to iterate on this. So move on to slide number 2. So can you see slide number 2? So in this presentation, I'm going to cover the materials, how to apply the material from the application perspective, what is the specification, as well as designing with the codes. Next slide. So GFRP material, if you look at the rightmost artist impression, the blue color, polymer matrix mix is our formula proprietary compound, whereby fiber reinforcement, the real photograph I take from my production floor, is at the bottom. You always heard about nanotechnological based technology, whereby we fuse many thousands hairline string, just like diamond, you polish millions times, it derives into nanos form of a fiber, where the originate of the component is actually silica sand. And then you bias it minimally with a proportionate mix, where the photo courtesy from us. This is one of our mesh production. So conventionally, this material used in aircraft, high performance car. So now cruise is a trend now. If you hop by aircraft or cruise, just take a note on it. It is not made out of steel. It is FRP material. So this material has been in the industry for the last 80 to 100 years, in construction for the last 50 to 60 years. That's why the code already exists. Next. So comparing glass fiber reinforced polymer against steel. Most important is the durability or the strength perspective. Number 1, the tensile strength minimum at 1,000 Newton mm square, all the way to about 1,500 Newton mm square, compared to steel about 500. So from this data, it is 2 to 3 times higher compared to steel. Costing, okay, projected at 10 to 15%. Stay tuned a little bit more. I educate you how to save more using GFRP. In respect of weights, this material is 4 times lighter in weight, 4 times lower density compared to steel. So when it lighter in weight, it actually save up the labor force at site, or save up the timing of construction, which is additional saving from the material and design. So for example, your 10 workers handling of 100 pieces now a day at site, with GFRP, 10 workers potentially handling of 400 pieces at site. So assuming the site need you to work at about 1 month to complete casting, this site allows you to less than 2 weeks of complete casting. So we live in a beautiful country of Malaysia, whereby our construction 12 months without bothering of weather, freezing and thawing. So it's time to look at elevate our construction landscape to a better construction landscape which on par with first world country. Another advantage for this material is electromagnetic neutral. So it doesn't conduct electricity or penetration of wireless signal. So I'm sure you heard about it, like lift is made out of steel, right? The higher floors you go, it will actually cut out your signal of your mobile phones. So we encourage you, migrate more to GFRP, your signal transmission will be better because this is an electromagnetic neutral, number one. Number two, eventually, if you use a steel scanner or metal scanner, it is not able to scan it. Because I fly around with my sample all around the world, it gets through the checkpoints. So that's beside the point for the construction. But the advantage is that the penetration of signals, it allows you like MRI facility, it can transmit the signal better, which I will talk about it in later on my slides, and handling. So due to lightweights, it ease of handling at site. So in our country, we are promoting back more of a local content of a worker. This is one of the way. When you shorten up the workability, in a nutshell, you can actually increase their salary or workmanships at site as well. So most important, the originate of this material, the bond of this material is actually corrosion free. I'm not sure how irritated you are with this statement file. So, you know, when we are home purchaser or any property purchaser, you are actually bound by 2 years defect and liability by the main con, 5 years from the SPA. Otherwise, dearest bankers, I need you to hear this as well. We are getting finances 35 years max from you guys to facilitate, to finance the purchasing of the assets of property. But after 5 years, any defect and liability, we actually have to fork out additional expenses to actually cover it. Actually, a lot of times happens in country like Malaysia, the corrosion and the cover are not as profound as first world country like Australia. So it's time for us to actually look seriously into this fact, because corrosion is just like cancer in the body, a cavity in the teeth. It don't die off tomorrow, but it's just the matters of time. So the last we talk about carbon tax. Carbon tax is just the acceleration and incremental of the urge, the change for us to reduce, to help to impair the carbon emission. So how bad actually the carbon emission from the construction to the industry? Next slide. Construction industry accounts for 38% of carbon emission data by International Energy Agency. So the concrete manufacturing accounts for 7% and steel accounts for 6.7%. Play the video. So fiberglass being the lowest emission in the world. So not just combating
example,
against
for industries,
corrosion.
you know, when it comes to carbon emissions, we have a target for certain industries. And the biggest carbon emitter today in the manufacturing sector, for example, is steel and cement. So we're talking to the Ministry of Finance, and the Prime Minister has already announced that next year we will start proposing carbon tax. So
okay, so let's look at the carbon emission scope 1, the table on the right. So if you look at the weights perspective, that means same size, A7, if your contractor is common to you, A is a spacing of 200 by 200, 7 is a diameter, similarly to other countries. So the weights per piece or kilogram per meter square for steel is about 3.02. Then for GFRP, Starbus is about 0.76. If you look at the carbon emission per kilogram per CO2e, steel and GFRP mesh both contributed 1.9. However, the 1.9 CO2e applies for steel is 1 piece. The 1.9 apply for GFRP is 4 pieces. Therefore, if you compare 1 pieces of steel, same sizes to GFRP, GFRP emits 75% lower compared to conventional steel. Next. So this material, compared to steel, it is lesser stiffness, low E values, linear elastic up to failure with no ductility and anistrophic. So for engineers, if you look at the stress strain curve on the right hand side, the blue color are actually steel, it yield at 500, whereas the orange color and the purple line is GFRP Starbus. The stress point is 2 to 3 times higher, whereas it don't ductile. So for more technical quantification for dearest engineer, you can participate in our technical workshop organized by IJM Negeri Sembilan next Tuesday. So if you have a lot of concern about this material on ductility and durability, go to the next slides. I need to hear this video out.
address a lot of the misconceptions out there. People are saying, hey, Bona, fiberglass rebar is brittle. It doesn't give you the warning. It doesn't do this. It doesn't do that. But we have done a lot of testing. This test has been done in the University of Concordia. This is a simple beam, 16 feet span from center to center of the support. This is a 300 millimeter or a foot long high concrete, regular concrete, 6 inches, and 2 pieces of number 5 rebar running at the bottom. And we put this at a cyclic loading of 2 hertz, 2 cycles per second. The loading on top is 25,000 pound force or 110 kilonewton, 1.7 times service load. And this video has been recorded after 2 million cycles. We did the same test with steel, and it only lasted less than 20,000 cycles.
See, 2 million cycle GFRP versus 20,000 cycle. This material performs 100 times better than conventional steel. Next. So the next one, we are talking about application of GFRP into reinforced concrete. Next. So we have done this thanks to the supporters. Some of the brand might known to you. People like EcoWorld, the entire business Part 5 are our user. Or the Malaysia Book of Record winning water park in Penang, a little bit promotion for them because it's built by Starbucks, both resort and the water park. It's a 5-star rated hotels, and CIDB last year, the workshop was there. I was one of the speakers. So please support them, as well as go to the affordable homes brand, Legenda Properties. This project is at Ipoh Meru, next to the North-South Highway. Should you need a site visit, just feel free to give us a call. We can privately arrange you for any of the site confirmation. Next. So having said that, this material is even more superior into marine chloride application, de-icing chemical application, more sustainable bridges, and electromagnetic transparency application like MRI facilities or airport radio without signal disturbing areas. Next. So this material as a good alternative to the reinforcing concrete. Later, I come to the codes and the elements usage. You cannot just limit it to residential, industrial, or commercial. And for those who build MRT, it can be your tunnel boring machine coring through the diaphragm wall. It is easier to core through GFRP compared to steel. At the same time, MST rebar, my competitor, have done this in the critical piling as well. Next, these are more interesting to you, cost savings. So material to material, assuming same sizes. So dearest listeners, for those who are listening, if you screenshot today, prove that you are today, you go to my website, crtm.com.my, call us. I will pledge you additional 10% discount from this. Just a courtesy gift to all participants today. For those who heard it, for those who never heard it, that's all right. You still entitled the savings that is iterated here. And then if you go to value engineering, we are engineers in our outfit at the same time. So we are able to downsize certain reinforcement size that allow you more savings from same size reinforcement. Or some of the project, we can minimize the concrete usage without discount the safety, durability, compliance to the code. Let's go to a little bit more technical, the 3-legged compliance. Next. Okay, so this material, you need to have a product certification license strictly from CRIM, ASTM D7957 got CRIM, you beli, tak ada CRIM, jangan beli, because this is the spec. ASTM D7957, there are necessary specification, testing, compliance, number of samplings, and audits requirement. Then, dearest engineers, civil and structural engineers, you need to comply BSEN 1992-1 version 2023, not the 2004, because annexes are starts from page 384. You are able to design this, or American code, specific code, ACI code 440.11, which is in synchronized with the steel design ACI 318. So for the application at site, you need to comply ACI spec 440.5. It's not like suka-suka, I like to lap this much means this much. Allow me to educate more. Next. So conventionally still, you are using BS 8110. I know. And then the old Euro code. When it comes to GFRP, you need to follow the new Eurocode. Okay, so the new Eurocode as well as the new American code, and we are in the drafting of the MS standards as well. So if you are not using this code in Malaysia, next slide, you can actually comply to like China code JGJ 323, year 2023, the same year as Eurocode publication for GFRP. If you are from Australia, you can follow AS 5204, year 2023, the same year as Eurocode published. Indian code IS 18256, also year 2023. Canadian are earlier, CSAS 807 2019, and Indonesian are actually ahead of Malaysia a little bit, SNI 8970 2021, but country that is not listed here is just not common for my client referral, but that is not limited, restricted to this table only. Next. So for Eurocode EN 1992, the latest revision, page 384 onwards, if you look at the design criteria, it covers all structures, beam, slabs, column, foundation, and so forth. If you go to the American code next, American code, most of the chapter, you have to follow the relevant chapter for the right design for the structural use. Next. So the construction specification, we need to strictly follow ACI spec 440.5, which will include strictly in our method statement. Next. So this is the front page, 440.5, published year 2022. Next. So to easy handling this material, play the video. This material is a quarter of the weights. You can step on it, more durable, bend and flux back. So unlike conventional technology, it look like plastic, look like rotten, but stronger than steel, easier to handle compared to steel. This is just to show you it sounds like steel, work like steel, no special handling. In fact, it's easier cuttable as well. So to reduce wastages at site, you can actually order cut to size from us. We will issue you the shop drawing. You can work on it, bend on it, 2-person carry one piece. You won't see conventional steel market able to do this. 500 pieces of BRC, British Reinforcement Concrete, to take it down, the steel, to unload steel, it takes 2 hours. To unload GFRP, it takes only 35 minutes. Next. So for storage and handling, this is from our actual site. So nobody going to steal anymore because they cannot commercially recycle it easily. However, with special processes, it can be recycled. So it solves one of the advantage that critically save your pocket. Number 2, it does not rust or corrode at site. So you do not fear or worry the quality will impair at site. Number 2, you still need the bar chair, assuming your top bar, bottom bar, your concrete tofu block or your bar chair, you still in need is the same. From tying perspective, you can use a normal wire tie to tie it. Next. So this is from one of the table from the codes. The cover is no substantial different from steel reinforcement. In fact, pursuant to EN 1992 is slightly lesser because this material is no corrosion or corrosion free. The major difference is, next slide, whereby this material, you cannot easily bend at site. So in the site present moment, they are hybriding with steel. So area that a lot of bending steel is still advantageous. Next slide. So if you look at this video, the yellow color bar are the cross wire of GFRP. This purple color U bar made out of steel. So you cast it along your panel, and then there are main wire, which is the green color bar. Then subsequently you pour your concrete. The green color bar can be GFRP as well. So only the anchor, T-bar, L-bar, C channel is made out of steel. The lapping requirement same is still 40 multiplied by diameter. You can tie with conventional wire tie. Next, designing with the codes. So this is only one of an example. Next. So if you talk about longevity or durability, if you compare the Eurocode steel design versus FRP design, you have to crack control and serviceability control it well. You are able to have a concrete saving of 15% or reinforcement saving of 22%. For more detail of checking and design, you can participate either IEM Negeri Sembilan next Tuesday or 28th of November, Association of Consulting Engineer Malaysia. I will give more technical calculation like this. Next. Fire rating is everybody concerned. So if you look at Eurocode practices, say 2 hours fire rating, you need 120 mm to pass. We tested at BS 476, 78 mm already passes 2 hours fire rating. Otherwise, refer to the code, the commentary, they are necessary, cover, recommended, complies to the codes and UBBL for fire resistance design. Okay, next. Maybe this rumor might cross your ear. If should it happen, cross to you, do cross to you, just give us a call. Because there are rumors outside saying that using Starbar now tak crack, after a while it cracks. Probably from what we observe from our site, from Tanjung Malim, Kapar and Subang, area that uses steel, which is the left photograph, it cracked all the way without loading. Area that uses Starbar, if you look at it, there are 3 stacks of pallet, 3 tons. It's only derived on string cages crack. And there is another site actually cracked at the slab. So we requested the site to do a coring test. Core results come out, the concrete strength does not achieve the design strength, and also the thickness does not achieve about 30%. So mainly, primarily due to workmanship. But Nema is okay. Should you came across any of these anymore in the future, do give us a call. We can arrange a private session to verify, clarify these things to you as well. So next. So CRT, Composite Revolution Technology. This is our manufacturing plant, one and only in Malaysia, section 16 Shah Alam. Standard sheets, this is what you see. We can do cut to size to have no wastage for you. So this material is very lightweight. This is the fiberglass roving, the nanotechnology. From far to look like tali raffia. If you close up, it will be like page number 1. Each of the bar fused by 20 to 30,000 hairline string fusee derive a good tensile strength and bond strength to the concrete, because the main primary material are silica, which is the primary glue material to the concrete. So this is our processes, real processes. Actually, I want to do live here so that you guys can see it real life, but it's okay. You got our contact, arrange a private session with us. We can bring you around as well. So these are our matchmaking directly from the raw material to the end finished goods. So probably a piece of these standard sheets, we do it faster than your A3 printing in your office. So discover together with us. For more, contact us in the very near future. You can reach out to us in our website or Google. You can actually find us as well. Or go to TikTok, you'll find CRT Manufacturing. You can see a couple of updated videos at all time. Follow us for the updated workshops. Next. So for this material, we have sufficient green certification, My Hijau, CREM ISO 14065, MGBC, GBI, and a recognition token from GreenRE. For product certification, we have 2, both from CREM. At the same time, we are local patent and My STI, which enacted in the new Perkeliling to encourage the adoption of local design products. We are not OEM from any first world country. As I mentioned, I'm one of the inventor in our team. Do support us as a local invention and commercial. Next. So to use this product aside, thanks to CIDB, a good support. If today you Google CIDB Starbars, you are able to see us in the website. And some of their workshop tours, you can see I'm one of the speakers. I know the photograph looked different from me. That was me many years ago. So this is the letter supporting by CIDB. At the same time, next. All the technical workshops we conduct through Institutional of Engineer Malaysia, Board of Engineer Malaysia, Institute of Civil Engineer Malaysia, upcoming Association of Consulting Engineer Malaysia, as well as Surveyors Congress to have the right quantification and costing. Next. Principally, that's it from my side. I'm a co-founder and one of the inventor for Starbucks. Here is my contact. If you feel free to drop me a WhatsApp or give me a call at any time. I should be able to feed you the right information the soonest I can reach out to you. Have a good day. Support local technology, support Malaysia. Let Malaysia pioneer for the world. Thank you.
Wow. Thank you, Messi. For a while,
Yes,
I
that's
felt
all
like,
for my part.
yeah. I just wanted to wrap up saying, you keep on saying, let me educate you. Yes, indeed, it's an educational, informative, and a very technical talk from you. I pick up this. It's an alternative material. Malaysian made by Malaysian, made in Malaysia by Malaysian, all right? And you keep on marketing that. And I think it's a timely reminder that we have alternative material. Thank you for that sharing. I can feel your little bit of pain. Maybe we can share later on. No, because I can feel that pain. Why keep on marketing it? It's Malaysian made. Why don't you guys look into it? Thank you for that sharing. I felt like suddenly I went for some engineering classes for a while, looking at all that. Thank you. Ladies and gentlemen, I know we are on virtual, but do give a round of applause for both those speakers. Then we move on to our third speaker, Dr. Govind. Are you ready?
Yeah, I'm ready.
Ladies and gentlemen, let me introduce Dr. Govind. He is a civil and structural engineer, over 30 years of experience in Malaysian infrastructure project, forensic engineering, sustainable construction research. He holds patent, and his PhD was focused on use of industrial waste material. Today, he'll be sharing us on a topic which is talking about his exposure in sense of material. He gives us an insight. Dr. Govind, ready? You can show us your slides. It's easier. You can, while I'm introducing to you.
Okay, can everyone see my slide?
All right. Yeah, good. It's on a slide mode. Ladies and gentlemen, do welcome Engineer Dr. V. Govindarajan on low carbon material and circular construction. Dr. Govind, over to you.
Thank you, Mr. Ramesh, as a moderator for these topics. And earlier speaker, Dr. Khairolden from CIDB. In fact, I must say that I've been also working closely with one of your previous director for some of my testing on forensic works. I use always CIDB for lab test and all that.
Very good.
Yeah, and thank you, a special thank you for you, and also Miss May. Actually, I probably will share some of my experience on forensic work where been noticing a lot of concrete spalling is a way of concrete cancer that we've been seeing in many of the buildings that I've been auditing lately, high-rise buildings. So there you have a good market, I would say, later. So let's move on. Yeah, thank you. So background, a bit of background. So currently I'm actually a director of a consultancy company. We are mainly on the geotech, civil and structure design. Because my research focused more into forensic on concrete structures and all that. After graduating with my PhD, I focused more into forensic engineering, where I've done quite a lot of defect structures, concretes, and integrity assessments. And many times I also become expert witness in a court hearing where sometimes there's a dispute between contractor, engineer, sometimes also developer. Not very good way of it, but this is something that our expertise been requested, so we attend to it. Now, interestingly, when this topic was given by Mr. Ramesh, I realized, in fact, my research that was done in 2003, the title is The Development of Low-Cost, Low-Energy Cement. So I think the title, I don't know whether Mr. Ramesh, you got the title from my research or you got it on your own or whatever. Anyway, that's talking about almost 20 over years ago. we already explore into this in when we were doing my research in UK, Wales. So now I will talk later on that how other countries, especially UK, they have actually given importance on this sustainability with a closely collaborating with the industrial partners. Perhaps that sort of ideas can be implemented in Malaysia, which I would also recommend in the end of my slide. Now, this background of the greenhouse gas emissions, I think this figure, Dr. Khairolden will have the latest figure, but this also I got it from one of their guidelines that are available. So what is the point here? Actually, the construction industry alone actually produced almost like 76 million tons of CO2. Okay, this is they call it carrier to site and all that. Which out of it, I think the construction materials, 90% actually comes from the construction materials. I think that is why I think they are given emphasize low carbons and circular construction, because that's how actually you can minimize this gas emissions. Yeah. So now, if you look at the having some problem. Okay, so I think globally, everyone, this one can Google it and you can find out. But the point that I would like to say is that the cement production, which is the main component in the construction industry, the manufacturing use almost 2% of world energy that produce of 5. Now, this percentage can be also a different 5 to 8% and all that, or CO2 emissions. So to give a figure, 1 ton of cement productions is required 2.7 ton of raw materials that required 124 kilowatts hour power, right? So that's a major component of materials in the building industries, right? Construction industries. So basically, we need to find materials that can produce a low carbon, as well as the circular constructions play a very important role to ensure that the materials within the same loop they utilize. So the table below here is actually give an idea major construction materials. I think Ms. May actually elaborated on the steel reinforcements, the gas productions, I mean CO2 emissions and all that. I don't want to talk on that in detail, but focusing more into concrete industry, how we can minimize and all that. Yeah. Okay, so now this is the earlier I spoke that some say 5%, but it's in the range of 5 to 8% the carbon's CO2 emissions actually produced, right? So now what is actually low carbon materials? Now low carbon materials is and you call bio-based materials such as like, you know, wood, that's so many materials like microalgae. These are the certain materials that can be renewed, recycled or renewed. And low embodied carbon materials also like certain pozzolanic materials, which I will talk later. And there's also today we have a combinations of a normal conventional cement with the other materials, which is known as a geopolymer. So geopolymer is a new revolutions of materials. Now, I think sometimes we have to look into combinations. As a design engineer, when you have a high properties of strength of materials, definitely the thickness or the size of the materials can be reduced. For example, Ms. May was telling the tensile strength of the star bar is actually 3-4 times of a normal steel. Normal steel today is about 500 megapascal. If she's talking about 1,000, obviously when you put in the figure, the entire thickness of the member can be reduced. Similarly, also when you use geopolymer cement, which is can reduce the thickness of the concrete use, because all go back on the compressive strength of the cement. If you can produce 200 megapascal compared to conventionally now 30 megapascal to 50 megapascal, obviously you can reduce the thickness of the materials and directly benefit industry will benefit. So I think this figure also, our Dr. Khairolden, I think, did mention a good effort they are putting on the calculator. But I just want to show these two figures to show that what is actually the conventional cements actually they produce, the CO2. So it's every about 0.74 kg of CO2 is produced for every kg of cement. So you can see of the amount of CO2 is produced compared to GGBS, ground granulated blast furnace slags products of steel. This thing, it's only about 0.04. So you can see the difference. So these are the materials you need to combine to have a sustainable cement or low carbon cement. Yeah. So why low carbon in constructions, low carbon construction materials? I think this is, I think earlier speaker also spoke in depth. I think different materials, if you can recycle or reuse, combination of materials definitely will benefit the entire construction industry. I think the new regulations also, interestingly, I think about last week, I was listening to BFM and they were talking about carbon tax they're going to implement next year. I'm sure moderator Mr. Ramesh can elaborate on that. We all are very eager to know how they're going to impose this carbon tax, which in a way, I would say that's a very good move because without those enforcement, I would say, or regulations, I think we will never go into a sustainability. Now, I must say also, I know some of my family members, actually, they're already working towards this sustainability. A banking sector, interestingly, one of them is working in Kannada, I think, finance, where they have a master plan. They've been working on the past 2 years, it seems, where they have a checklist, actually. Banking sector, they have a checklist. So when you apply a loan, I think they will have a certain criteria that this industry have to meet in order to entitlement for the loan. I think that's a very good move as well. Yeah. So I think these combinations of low carbon materials and circular constructions, it's all together, jarred together. So if these two things can be utilized by the constructions industry, definitely a lot of things can be minimized. Even waste going to the landfill also, some of the materials, byproducts of materials that they're dumped into a landfill also can be reduced. So that's a very good way of to have a clean environment as well. So there's in countries like Europe and UK, I think they are mandating this embodied carbon into the government's regulations and all that. I think even Singapore, they call there's a buy clean kind of policy and all that. So end of the day, I think it's very important is innovations. So we need to have a continuous innovations in terms of both utilizing the pozzolanic materials or byproducts into a construction industry by directly reduce the conventional cement. Now, here I'm going to just brief a little bit on my research. Actually, like I said earlier, the development of low-cost, low-energy cement, where we use actually waste paper sludge ash. Okay, so it's a byproduct from the paper making industry, and we combine with GGBS, which is the ground granulated blast furnace slag. We start blending this into concrete products, and then we introduce some other materials. So why these materials were selected? I think previously, before even I start taking this research, there was some paper or some research was carried out by my University of Glamorgan. And one of the things is that the paper manufacturer, they actually collaborate with the university to find an alternate for these products, because there's a huge tax actually been imposed to dump. For example, in UK, the time was 5 million tons of waste paper ash was dumped in landfill. and they have to pay a very high amount to dispose this material. So they are forced actually to find alternate products, for to utilize. That's how the research came into the university's mind. So then, end of the day, the research is not a very straightforward. This research. Many people ask me, "What are you doing for 3.5 years research in this?" Actually, any products to come, I think Ms. May also will agree that in order for you to put this in the market, you need to have a very extensive kind of R&D and also test result to prove that this material is strength-wise is good, durability also good. So that is what actually we have been studying the entire of my research, from the cementitious materials to the type of mixed proportions, like a fruit cakes you make, until the things goes to the industry, and how it's work. Now, why I'm saying this, not every byproducts you can straight away use and then can produce as a cementitious replacement or partially a cementitious replacement, because if you are using in a different proportion, it can give some side effects as well. Now, must say that the pozzolanic materials, like as I mentioning earlier, GGBS, fly ash, or some other materials, metakaolin, all these materials, it's not a new materials being used. Actually, these materials already been used elsewhere. One of the reasons why these materials become a superior is actually it's give a very good durability performance, right? For example, if you are using a high cement contents PC, normal cement without controlling, without proper curing, it can lead to a micro crack. Now, I was in the sewage treatment plant industry for many years, and I was a resident engineer, where I've seen actually the micro cracks due to thermal temperature and how this can be caused later as a major crack. So many times the concrete actually cracks in the early stage during the setting time, but that's not noticed. And if you're not noticing, the micro crack become larger and larger, and one day the cracks become serious to the structure. Yeah. So to give some, maybe some of you are industrial engineers, they understand what here this slide all about. Like I said, so the pozzolanic materials itself, as I said, it's as a two divisions. One is a natural pozzolanic, and another one is artificial. So the natural is a volcano ash. Pumice is one of the best natural pozzolanic materials. The rest is fly ash, GGPS, silica fume, our waste paper sludge ash, rice husk, palm oil and oil shell. So this I must say that the rice husk and palm oil shell been utilized in research by our local industry. I know for that matter, Professor Dr. Manan used to be in University Sabah, and then he moved to University Sarawak. He has done quite a lot of research on this product as well. So we are not, I would say we are working on alternate materials that in some of this university, they are working on this as well. Yeah. So the combination of these materials with the Portland cement, it's become a geopolymer. So that's the one, the new revolutions type of cement we are using. So for those chemistry, the mineralogy, it's all go back to these three main component of calcium oxide, aluminum oxide, and silicon dioxide. So the proportion, like I said earlier, the chemistry of these actually will give you a rapid hardening cement or sulfate resistant cement, a high alumina cement. Everything comes in this triangle mineralogy of the chemistry of the cement. So those who want to know more on this, you can contact me separately after this. I can give you a lecture on this. That will take probably also a few hours on that. So I'll move on. So now, like I said earlier, interestingly, when I was doing my research, if some who studied in UK, the second seven crossing in UK, the connections bridge between England and Wales, just at Bristol, the concrete they use, this support of this pier, actually 70% of GGBS and 30% only PC. imagine, I'm talking about 1996 actually. This is the year I graduated from my university. So the use of this sort of low carbon cement actually been already used elsewhere, and it's superior in terms of the chloride resistant, high chemical resistant, also ASR, alkali silica reactions, and it's very important, it has a low risk of thermal cracking, where in UK or in the Europe country we call freeze thawing. That means the temperature drop to minus, and then the summer temperature goes to 25, 26, or even 30 nowadays. So the concrete should stand with all these kind of tests. I mean, all kind of the environment, yeah, industrial environment. Now, I think Dr. earlier, Khairolden already talked quite a lot or lengthy on this in Malaysia policies and all that. But I think we are there. I think they are working on some papers there in terms of lowering the ground. I mean, green building, greenhouse gas, and the studies also they're utilizing bamboo and recyclings are being studied elsewhere. Yeah, that need to be continued. And I think the projects also, I did found this, that some of these projects they have utilized. I think probably I need to add some of these projects that Ms. May was quoting earlier, Eco World and Veerappan Properties and Legenda. Also, maybe I need to include into this presentation that some of the sustainable materials or low carbon materials being used in our Malaysia. Yeah. So I think the challenges, again, I would say based on my experience that in order to make sure that the industry or the players to use this kind of materials, I think there must be some a formula to be in a way intensive or incentive, or little bit of forceful to the industry to make sure that they use, which is banking actually, they're using that actually formula. I think some sort of marks or assessor will give in order to secure some loan from the banks if they have this kind of implementations in their companies. Yeah, and also I think without research by universities and all that, I think we may not develop, we may not go in depth. Yeah. Okay. So I think, like I said earlier, the stakeholders play a very important role here. They must join, or they must allocate some of their whatever the revenue for the R&D collaborations with the universities, and of course they can have the whatever the invention, they can have a patent, and they can always market like Ms. May was doing. I think we need more of this kind of industrial players to come forward, into this low carbons and circular constructions. So now I think one of the things that I picked up from our first speaker, Dr. Khairolden, was actually the UBBL, Uniform Building Bylaw. Now, being an engineer, professional engineer, I think that's also another way of actually, we can actually include, it's a time probably I would say to revisit our condition of contract or specification for that matter in IEM, JKR, CIDB, they have a condition of contract, PAM, to include these low carbon materials and circular constructions, So it has to be specified in the contract, whereby the contractors can look into this as a part of this. So me being a consultant as an engineer, if I'm specifying something or some design, maybe I can look into certain type of materials for sewerage industry, for that matter, sulfite attack. So I can say that, okay, you need to, for sulfite attack, you need to use this kind of cement, which is actually superior in terms of durability. And also I can say use Saba rebar, instead of using a conventional that can have a corrosiveness and all that. So that's how I think consultants also need to have a big role here, where they can actually include in their specification or design, or even in the condition of contracts. Of course, it's drafted or being used within our construction industry. I mean, within Malaysia, unlikely FIDIC, where the French law. So that's become international contract become maybe difficult to implement this. But I'm talking about the local condition of contract. So I think they have collaborations. I think I've noticed they have net zero targets. By the time today, in fact, I was giving these talks, I also heard in Sarawak this morning they had actually a net zero target talking about. So is this the topic now everyone is talking about actually? So it's good. So there's the same time everywhere they are talking about that. So I finished my presentation. Thank you. I don't know whether it's early or what, but I pass on to our moderator, Mr. Ramesh. You can take over. And
Thank you, Dr. Govind, for the informative session, and you touched in many aspects in sense of a concrete of a lower carbon. I like the way when you touched it on a contract itself. Very informative, very informative. Give us an overview of the whole circular construction. Ladies and gentlemen, if you realize we had 3 speakers, and they are from policymakers. They're also academicians. They're also industry players, and we have a consultant. So we combined speakers such a way, and I'm also from as an industry player, and we touched on 2 major materials: rebar, concrete, and how the policy from embodied carbon. So we actually intertwined the key material, rebar and concrete, and also the need for embodied carbon calculation or lower carbon calculation. So this is what I would say the way that we put up this session. And the whole fundamental of today's discussion is about circular construction, and it's the change in mindset from a linear construction to more to a circular construction or closed loop method. You know, the linear construction, people always say, take me and dispose. Or use me and dispose, that's kind of a thing, or dump it. We have to move away where, either repurposing, recycle, reuse. This is what our speakers keep on talking about. And Dr. Khairolden, you spoke about certification, need of certification, embodied carbon, the availability of SB mark, the database that we are slowly building up. Mei Si, you spoke about alternative material available. I like the way when you said we have low carbon emission material, we have a choice versus the traditional material available, but better, all right? We have better, change is required. Dr. Govind, you touched so many things into your research itself about using pozzolanic material, and that's giving the insight about that. I also liked when you mentioned a marriage of, and you say, you're using a star bar. It actually reduces my concrete thickness. That's what we needed. People have to get together. That marriage is required. Ladies and gentlemen, to quickly sum up with all of our discussion, I will move on to the most important section, which is Q&A. We can see there are a couple of questions I will address. I have burning questions, but we'll give room to all of our audience. Let me pick up someone. This is Ms. Mei Si. I think I will give it to you first. The question is this: can GFRP be used to give buildings more flexibility to withstand earthquakes or tremors, similar to wood?
At present moment, pursuant to the design code, no, it cannot be done. It can only be done according to seismic category A, where it's minimal, limited to minimal, because this material is not ductile. So eventually we will still improve our research and development. Probably in the not far future, we are able to do it.
Thank you. Okay, now I'll move to Dr. Khairolden.
Yep.
Dr. Khairolden, there was this query from our audience. With the calculation being digitalized, is there any need for professionals or people seeking to enter environment or sustainability to be certified in carbon calculation?
Thank you for the question. Actually, as we are growing together, right? So we need a professional to be certified. So not only for the digitalization, but as of now, we are not put in the compulsory. It's still the voluntary, and a lot of things we need to do for the professional certification, because this is ongoing process. Way to way, right, is to make sure that the professional can make a decision making, right, in terms of validation, in terms of auditing, regulatory compliance, and so on, right. So this because the companies right now have to disclose the scope 1, scope 2, scope 3, right, the emission. So these are the things that not only for the digitalization, but as for now, we also in future, we have to get a professional to be certified. But right now, we have still a shortage for the professional on this certified professional in the carbon, right? So I think that's some of the strategy for the long term for the government to look into this professional certified, right? Thank you.
Thank you, Dr. Khairolden. Dr. Govind, I think you'll be the right person to answer this. The question is this. Considering, no, I'll read it out to you. You say, okay, we can, I believe so. Let's see. Considering the Malaysia is moving towards an aging population, is there any mandate that at least one bathroom in the house be aged people compliant, so as to reduce resource wastages to later renovate bathrooms? So the person thinks, if we are mindful about the use of the building, and in such way, you don't touch on so much on renovation or refurbishment, and that will there'll be reduction in sense of the wastages, in sense of use of material or refurbishment. Now, would you like to take it?
So I still didn't get the exact. This was the questions. Again, can you repeat this?
Okay. Probably. The question is this: whether the building must be designed to be aged people, not elderly people, compliant, so we don't renovate in such a way the bathroom. When you renovate, of course, there is a demolition waste, etc. No new materials are being used. The person doesn't. Can we just specify it? I would say if to mandate, we're not sure. Maybe it should be coming from the authority. For us, rightfully, you think about the use of the building. The universal design codes are available for differently able people, and also for aged people. So whereby the building are designed such a way to cater for it. Yeah, that would be a right thing to do. Example, even my home, when I renovated earlier my bathroom, I wanted to be compliant I have a mother, I feel like, I needed a bigger door. A normal bathroom size, the door may not be wheelchair accessible. Yeah, that'd be a good thing but mandating, not sure.
I think the questions itself is a choice. It's not something you can enforce not to do renovations. I think for as an industrial or even as an engineer, I would say since they mentioned a bathroom, if the materials used in the bathroom construction start giving problems in terms of water leaking or corrosiveness or reinforcement, which always happen because of the failure of waterproofing, then you have no choice. You have to rectify. Otherwise, the defects becomes severe. The more troubling the owner, the user of the bathroom. So I think that's it's up to them. But if it's the aesthetic reason or architecturally they want to change or demolish certain things, it's up to the needs. You see?
Yep.
Yeah.
Okay. Let me see. There's a few more questions. Do we have enough time? We've got 5 minutes. Organizer, you have to tell us. If not, we will keep us informed on the timing. Let me take up this question. Okay, reuse and transformation of buildings rather than knock down and rebuild is more sustainable, but does not make as much as money for developer in the construction industry. Okay, basically they're saying, can we repurpose the building, rather than putting up a new construction, I think this will be covered into a different theme. There are a different panel for CGM that they're answering this question on urban oversupply. So they're touching on this topic. Probably, I don't know when is the session. Maybe we have to check on that because we are talking about this in part of our CGM talk about urban oversupply, where they are touching on exactly this question, whereby don't go to greenfield. Why don't you repurpose or refurbish your building? I will agree with you. Yes, we need to look into that repurposing. And I just picked up this question. I answered it. Let me move on to this question. Should there any control on over construction? In some countries, short-term rental industry displacing residents from housing estates or condominium. Basically, I think these two questions are tying back to earlier. Anybody else in our panel wanted to say about this? They're asking us why we're doing over construction, rather than repurpose and go for circular economy kind of a thing. Anybody else? Any thoughts, Dr. Khairolden?
Okay,
I
because
shared my
that
thoughts.
that's back to the policies of the government, right? So because this is not, we cannot force them actually to repurpose the construction, right? So I think this back to the policy. We need to revisit the policies. Is there any the request from the industry, from the customers, right? So I think it's a good for us to move forward towards the sustainable implement practices in the future, right? So that we can preserve the forest, right? So from the destroy of the everything, right? So this could be the way forward for the sustainable of the future. I think it's a good, right? But at this moment, it's not being practiced as a whole under the government, the Malaysian, as a whole nation. That's my some comments on that.
All right.
Yeah.
There's another question on whether we can comment on whether there's a demand for residential property with a green or low carbon property versus a commercial property. I think I have to skip this. No, we are a panelist, very much. We are technical guys. We are talking today. Our session is talking about circular construction, lower embodied carbon.
I think our CIDB, I think it was like Dr. Khairolden was saying that they are actually working on some database and all that.
Yeah.
I think maybe from now onwards, that can be monitored. I'm sure we have a green building measurement, green building index measurements and all that. But the database, how many buildings have that certificates of, it's all that's, I think CIDB will have in archive, and then the future comes with after your carbons records, then that will be a measured for all the buildings in detail, because at the moment we only based on GBI, you see?
Yeah.
There are a couple of rating tools available. At this point in time, my exposure, my experience is more to commercial property, because the demand by the users, they understand that a green building lowers down the operational cost in terms of energy and etc. So there is a demand. Comparatively, residential property demand lesser. The uptake is maybe lesser due to awareness in sense of that green. I think this is what Mei Si also was sharing. Create that awareness. No, we have the material. Please, let me educate you the similar thing. Let me educate all the people out there. What is the green technology available? Why green construction can also aid you in many things. Lower the carbon, lower your emissions, and also save some costs. So these are the few things. These are the few questions from the audience. I have some burning question. Do I have time? At least for 3 questions.
Yeah, I think you can proceed, Ramesh. I think maybe 3 questions to the speakers, right?
Okay, Dr. Khairolden, since
okay, good.
Okay, that's okay. I'll ask Mei Si first. Mei Si, you turned something from concept into reality. What do you think is to make it more successful? I know you're marketing it, but what it really needs from you to make it successful, because the objective of this today is we want to have some direction, some policy. You have a concept, how to make it reality. What is your thoughts?
Okay, from the technical perspective, I think it's fully covered. It's more on a humanity perspective, because like Malaysian users, it can be from different targeted users group. It can be from contractors, QS, or engineers. A lot of time it is being governed not by physics, but governed by rumors. I heard something, but it's not testified. That's why I am here, just like the crack rumor. But how is actually you need to construct the right testing to find out what is the mistakes according to the workmanship or to the material. But then somehow they hurt because we are new material in the market, but we always being the first to be questioned. That is number one. Number two, the urge of change. Because there are some agency that we have been engaged with for the last 28 months. To seek for one meeting, probably it takes more than 30 months to get it, Then actually AI can answer you. Also, they don't get AI to answer and they conclude it otherwise and become a rumor in the market. So this is very much the culture that we need to mitigate so that we can actually move ahead quickly with the adoption of technology. Obviously, the existence, the born of this technology is not like 1 day, 2 days, or 5 years. So it's time to see us can accelerate it with the support from the agency to combat the climate and the urge and the needs. Otherwise, no matter how good technically and sound we prove the credibility, there is still at night they think about it, I don't dare to. So it's time to mitigate the don't dare to and give it a try.
Thank you.
Thank you.
Dr. Khairolden,
Yes.
being a moderator, this is a benefit. I can ask you all kind of questions, but we don't have much time. Circular construction. What are the main barriers that you face? And I know you're a policymaker, you also in some way a regulator, and you also being an academician. You have this few portfolio. What are the main barriers?
Right.
And any suggestion to overcome it?
Okay, thank you, Ramesh. It's a good question. So actually, one of the barriers actually that we are facing in the Malaysian construction industry is in terms of data availability, right? So the data sharing among us is still at the not satisfied, right? So because we have to share all the data in terms of verification, for certification, third-party verification, right? For example, EPD, Environmental Product Declaration, right? From the small manufacturers towards the big manufacturers. So number one. And also we have lacking in terms of infrastructure gaps, right? In terms of our readiness, the acceptance of the industry, right? To practice for the sustainable, as what May say. I do agree with you. So in fact, we need to create a platform for the industry to demonstrate their product, the newly product to be marketed for industry, right? So I think it's the best for now to create a platform. Maybe Cream can think of things for Ponder, right? To create a platform to gather all the good products, very potential product, to be one platform for the marketing, right? For the introduction to industry, so that the industry more confident to adopt this newly product to be used, right? So the next one actually in terms of regulatory requirement and policy, we are still short, and in fact we are still working hard for that policy, because as CIDB, I would say, it's not the purview of CIDB to look into the environmental itself, because it's looking for the construction for contractors, right? So the authority, I think maybe it's not the CIDB itself to look into that. As long as the authority must be under the different ministry that have to look, but the role and function of CIDB actually to look into, to promote, to encourage the industry players, right, to adopt the sustainable practices, right, to promote the product, the newly product, good product for to be used for the industry. So those are the things that the roles and function of I would say that the CIDB and the CREAM, from the perspective of research in promoting the sustainability program. So these are barriers, and also somehow how we can, promote in terms of regulatory, in terms of policy for the betterment of the industry. So that's my comment, Ramesh.
A little
Thank
bit
you.
for me to add on, Doctor. Thanks for your comment on
Yeah.
behalf of CREAM and
Yeah.
CIDB. A
Yeah.
little info from private players like us. You see, as
Okay.
an inventor, we struggle to mitigate the gap. Here, CIDB and CREAM are promoting new technology, same to my STI or mostly. But when
Okay.
you migrate to KKR or JKR, probably they take months to not update it. So it's time to close the gap among the stakeholder, that's so-called the government, to
Yeah.
us. Yeah, so
Yeah,
it will
agree.
lead from the communication.
Okay, thank you very much.
Basically,
I reserve the comment.
we have 66 participants here.
Yeah.
Oh, okay.
Probably, your voice is hurts. Probably someone there heard your voice. Okay, hope so,
Yeah.
right?
Yeah.
Thank
We are
you.
on the same boat.
Yeah.
We have another few more minutes. I will have my
Yeah.
last, I wouldn't say last, I have one question to Dr. Govind. Dr. Govind, you are a concrete forensic expert. You have some lesson learned in the industry. Based on that and additional things as a consultant itself, how you want to integrate circular construction into design of, doesn't matter, any assets or building?
I
How do you
think
integrate?
I think both together, low carbon cement or even circular construction materials, I think this can be incorporated. I think as being a consultant and also working on building audit assessment or structural integrity assessment, one of the things that we've been doing a lot of assessment is actually most of the building after the defect liability, they are actually experiencing defects quite badly. Now, I think I'm not sure to what extent they have actually used these the low carbon cement, like I earlier mentioned, the pozzolanic materials and all that, because it's no more waste materials. Although we say waste materials, actually it's a second generation materials that actually can be utilized in the construction industry for a benefit to have a high durable concrete actually. So I think that need to be included in their specification, or even to some extent in the condition of contract, draft a policy where encourage the contractors to use. I think for that matter, any tenderer, when you call for tender, if you include certain things in the tender, they need to find alternate materials to PC and all that. That will encourage them to look for other materials. But again, being an engineer, they really need to well-versed understand what actually they're specifying in their specifications, not just without sufficient knowledge. They're going to specify something and then that backfire them also. That's also dangerous. So they really need to understand what they're specifying in the specifications, or even during the whatever implementations for this in the circular constructions materials. So I think that knowledge as an engineer plus research is combinations will help actually to include that in the specifications or in the contract. Yeah.
So what you're saying is that capacity is required to understand the intended purpose of the asset or the structure, and combined with that understanding about circular construction, how to have a lower embodied carbon into it, and that will give you the whole idea. Of course, we've been thinking about linear construction. Now we're talking about closed loop, how to reuse the material back into the cycle. That's the whole idea. There are availability such thing.
For example, I've come across in water retaining structure, you're not supposed to use high cement, normal cement contents. Actually, the BS already specified limit the cement content. But they think high performance concrete is actually high strength concrete. Actually, they have failed to recognize the more cement you add, the higher actually thermal cracks going to occur in the concrete. And this thermal crack over the time will have a corrosiveness of reinforcement and all the secondary
Understanding the intended purpose. When you touched about pozzolanic use of pozzolanic cement, where it improves the thermal, etc. This is where the understanding should come in. So we don't have much time. We have another 5 more minutes. Let me just quickly wrap up all of our thoughts today. There's one more last question. Somebody's asking which project in Malaysia start implementing circular construction. All right, to think about it, any projects that are going for any green building certification or adopting lower carbon material, they are in some way adopting circular construction. Maybe you don't see the whole sum of it, life cycle assessment, but they are adopting it. Okay, ladies and gentlemen, with another 4 more minutes, please allow me, as your moderator, to summarize the outcome of this discussion, the insights and the thoughts of the mind today. This is what I captured. What we need is capacity building. Capacity building either through education or the professionals that we have, the agency we have on embodied carbon, lower carbon material, and how to use, and also to push the green certification. Next is adopting new material, like like what Macy said, even Dr. Govind and all that, which should come from design. Codes are available. How to incorporate it into design. And this adoption must start from which Dr. Govind touched. I need to put it into the technical specification. I need to driven it by the designer, the user of the building, or the developer. They need to put it as part of the contract specification or requirement. Then we can accelerate the adoption of the new material. If we don't put it into the specification, we will go back to conventional, how to increase that thing. Next thing is increase or enhance the awareness of this green material. What is the added benefit you have? It can lower down the cost. It can also have added benefit that we have to start thinking. It's not only environmental, it could be on a human health itself overall. And the pressing need to have a database on such material, availability of such material, the carbon emission, how to incorporate it into circular construction and designing. And finally, a platform is required for market players to showcase their material and the product available. This is the outcome, and this is the urge from all of us to the policymakers, so we can come up with something. All right, ladies and gentlemen, we come to the end of session. Without presence of you, 60 of you today, this session wouldn't be something fruitful, helpful, because all of us are sharing our thoughts and mind. So it will go around and make it possible to have a circular construction and a better environment. Thank you for joining as an audience. Thank you, all of you, the speakers, esteemed speakers.
Thank you, Ramesh, and the speakers.
Moving on, and don't forget, there you go, the last one. We have that Zoom survey. Please give us your feedback. It's important to us for us to improve. Again, thank you for attending. Thank you for being a participant. Thank you for being a speaker. Thank you for the organizer. Thank you for all the moderator and curators for this event. And please make sure that you stay tuned for other sessions that we have under CGM. Please do mark us. And until we meet again, thank you, everyone. Have a nice day.
Thank you.
Apologies if any lacking from our side. Thank you, everyone.
Thank you.
Have a nice day. Have a nice day.
Ramesh, Dr. Govind, May Si, and also the rest of the.
Go for circular construction.
Good.
Thank you. Bye-bye.